Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about algebra question number 783, minimum distance between BST nodes. Given the root of the binary search tree, return the minimum distance between the values of any two different nodes in the tree. Okay, they are asking us to find what the minimum difference between any two different nodes. Okay, let us understand this. Let us take this as our example. Okay, now see here, I can say what are all possible paths I can make? I can make 4, 2, 4, 1, 4, 3, 4, 6. Like that, I can make for this 2 and 1 and this 3. So among this, what is the minimum? I can say among this, the minimum is 1, right? The minimum is 1. So I output what? Can you understand this? So this is the question they have asked us. Okay. So the simpler way to do this is, first of all, I keep my pointer here. Yes. Then again, I'm going to traverse this entire tree without this 4. Without this 4, I will ignore this 4 and I will traverse this entire tree and check whether it gives any minimum value. Then I will keep this as our pointer and without this 2, ignoring this 2, I will traverse this entire tree and check whether that exists any minimum. So this is like what? I am placing a pointer here and I am checking in that whole entire tree. So it goes up to what? Time constant of n square and the space of t is what? O of 1. Sorry, O of x, because we are doing a recursion, right? We will do this in a recursion. So recursion will take that recursion stack and this stack will be having a space quantity of what? O of x. That means what? This height of this binary search tree. So this is the first approach, right? The brute force approach, right? Okay. Now, how we can optimize it? Okay, what are the properties of binary search tree? I can say the properties of binary search tree is, first of all, it is like all left subtree of a node is less than that and all right subtree value of that node is greater than that node. So I can say this is the first property of the binary search tree. Okay. Any other property we have? Yes, we have another property like in in-order traversal. In in-order traversal of a binary search tree, we will get what? We will get in a sorted order. We will get a sorted order. Okay. These three other property. How we can conclude with some solution? Okay. Let me take an example like 1, 2, 3, 4, 5. If I ask you what is the minimum difference between them, what do you say? It is 1, right? How? Because see here, whatever the elements, the elements which are nearer when it is sorted, any one of them will be a minimum value, right? Okay, let me take 1, 5, 8, 10, then 14, then 20. So here I want to check what? I want to check what is the minimum, right? So I will take this 1 and 5, yes, then this 5 and 8, then this 8 and 10, then this 10 and 14, then this 14 and 20. So it leads to what? 4, it gives 3, it gives 2, it gives 4, and it gives what? 6. So among this 2 is a minimum, so I will output this 2. Apart from this, we cannot get any further value, right? Any further minimum value. So this is the formula to find the minimum value. If they ask the maximum value, which we want to return, it is 1 and 20, right? Always is the property of the sorted array, right? If we want a minimum, it is in the adjacent side. If we want a maximum, we will take the minimum and the maximum element and do a difference. So for the minimum difference, what we are doing? We are doing the adjacent values. We are taking the difference of this adjacent values. Hope you understand this, right? The same exact thing we will take in this example. Okay, let me retry it. Okay, fine. Now, initially I am here, right? Now I will take my result in which I am storing my minimum and initially it is set to what? Float of infinity. Initially it is float of infinity. It's not into max. Now, I want to take the previous element because see here, if it is like something 1 by 8, 20, I will take what? This 1 and this 5, right? So for this 5, this is a previous. For this 8, this 5 is a previous. For this 20, this 8 is a previous, right? So we want to keep track on the previous elements. Okay, hold on. Now, initially the previous is what? Previous is -1. Initially previous is what? -1. Okay, now I am at this 4, right? I am at this 4. Now what we will do in in-order traversal? We will go up to the depth of the left. Then we will backtrack, right? Okay, go down. It is what? And null. So I will return. Okay, now what is the value? In inordinate transition, what is the property? It is left root, then only right? So I want to take the root second. So I'll take this 1. And already our pre is what? -1. So update is what? 1. Can you understand this? Update is what? 1. Okay, now I will go to the right subtree. It is also null, so I will return. Okay, now backtrack. While backtracking, what should I do? This is the current node, right? This is the current node. So 2 is the current node, and minus, what is the previous? It is 1. So it is equal to 1. So 1 is less than the float of infinity, right? So update is what? 1. Can you understand this? Update is what? 1. Now, when I go to the right subtree, now previous would be updated as what? Previous would be updated as 2. Previous would be updated as 2. Can you understand this? Yes. Now, again, it is 3. Now, again, I will go to what? I will go to the left subtree, right? I will go to the left subtree. Okay. Now, it also null. Okay, I will return. I go to the right subtree. It also null. I will return. Sorry, before going to the right subtree, what we will do? We will take the root, right? So, it is 3, right? Okay, 3 minus, what is the previous element? It is 2. So, take 2 is equal to also 1. So, already our result is 1. So, why we don't want to update it? Okay. Now, I will go to the right subtree. It is null. Okay. Again, backtrack. While backtracking, then I want to check whether this left and right are completed, right? That's why I'm backtracking. Okay. Now, this 2 is also backtrack. Now, I am at this 4, right? Okay, 3 is not updated. I want to update the 3 when I am at this node, right? Okay, now I am at this 4. Okay. It is a root value. We want to take the root value. Okay. Now, 4 minus 3. What is the value? It is also 1. So, already our value is not 1. So, we don't want to update it. Okay, now previous will become what? 4. Okay, now I will go to the what? That's right subtree. Okay, again I will go to the left subtree. It is null. Return. Okay, it is 6. So, 6 minus 4 is what? 2. So, already it is 1. So, I don't want to update this 2, right? Okay, now my previous it becomes what? 6. Okay, I again go to this right side. Null. Again return. Backtrack. So, I can say what is the minimum value? It is 1. So, we want the output was 1. Can you understand this? So, we are taking what? Previous and the current value and subtracting these both value will lead to what are like that. Okay, it is like a searching in a sorted order. Array is in the sorted order, and we want to search what is the minimum possible pairs in. So that's the exact approach here also used. Okay, we will do what? In order cell. Okay, tell me what is the time and space from t. Like I say, my time constraint will be O yeah, because I'm traversing each and everything in only one time. Each and every node bar or only one time. And what is my space from t? It is O huts, because we are using what? A recursive stack here. We are using a recursion, right? So it will take a recursive stack, and this recursive stack have a space of what? Height of this binary tree. So binary is 3, and the time also has space on t unless it's like this. So it is optimized, right? There it is n square. This what? Only n. Hope you understand this. Now let us see the optimal solution code. See here, result is equal to float of infinity, and tree is kept as what? -1. Now def tree of root. Now, non-local may result and non-local may pre, which means what? I'm just taking this both as what? Enclosed variable. So, instead of it, you can also take the variable as a class variable, or in C++ or Java, you may take this as a global variable or static variable. Okay. Now, if not root, then what should I do? I should return. If not root, I should return. Okay. Now, first I go to what? Trees left subtree. I want to go to the left subtree. Then I want to check whether after going to the left subtree, now it is a root, right? Now, if pre is not equal to -1, if pre is not equal to -1, then what should I do? I should just take the minimum upon the result and also the absolute value of pre minus root dot value. Instead of it, we can also take like what? Without taking this absolute value, I can take like what? Let me take it out. Instead of this, we can also take like root dot val minus pre. It is also okay. Why? Because always the pre will be less than the root's value, right? That's the in-order traversal. In-order traversal will be in sorted order. In sorted order, right side will be the greater value, right? So we can also put like this, and we are just updating the minimum value in this result. And each and every day, I will name this pre value as for root's value, right? And then I am going to the right subtree. Now at last, I am just calling this function, then I am returning the result. Let me submit it. Yes, it is submitted successfully. Thank you.
And the other 100.com.